Hey, morning, everybody. So, as mentioned yesterday and the day before that and all that stuff, every day we're going to do a warm-up. So in your notebooks, you should have this spot where it says a warm-up. If you're at home, you do not need to do the warm-up. But if you are here, you do need to write it down. So days you're here, write down warm-ups and learning goals. We're going to start on the first unit today. It's going to be heavy. Don't freak out. I anticipate this one being a rough one. I don't think it'll be the pace of the entire course, but it's got a lot of key stuff that we're going to need all year long. So let's dive in and see what we can do. Here we go. Warm-up today. This is right out of the textbook. I'm going to try to have most of the things out of the textbook. The textbook's online again through Reveal, so you got your logins there and everything. Number one, complete the mapping to represent the situation. What are they talking about? Well, copy down that picture real quick. 1, 2, 3, 4. These are terms we will define, domain and range. And in number one, it says complete the map and represent the situation. What's the situation? Anita is making chicken noodle soup. The recipe calls for 3 times as much broth as meat. So what in the world are they talking about here? Well, as we touched on yesterday, and we'll formally define today, domain is all the numbers you put in, and your range are all the numbers you get out. So this is what you're putting in, this is what you're getting out. In the context of this problem, number one, it says what? She's making chicken noodle soup. The recipe calls for 3 times as much broth as meat. So if you know how much meat you got, you could figure out how much broth is required because it takes 3 times as much. So this is kind of when they mean mapping, all they mean is we're going to take numbers that we're putting in the domain. We're going to do something to them, and we're going to get out. That's what the mapping thing means, get out something in the range right there. So if you put in 3 times as much broth as meat, and you put in, say, 1 cup of meat, how much broth should you get out, guys? Yeah, makes sense. There you go. 3 is in my range. You sometimes just draw arrows if there's a picture like this to say, okay, I start with these numbers in the domain, I do something to them, and I get out this number. Similarly, if you plugged in 2 cups of meat, you'd get out 6, makes sense, and so on and so forth. If you had 3, you'd get out 9. If you had 4, you'd get out 12. So that's all there is to number one. It's nothing too complicated right there. Okay, sounds good. Number 2. Let's see what that is. Write a function, it says, to represent the situation where x is the number of cups of meat. This is the meat right here, right? So here's x. And y is the number of cups of broth. And what'd you do with every single number that I gave you? When I gave you an x, what'd you do to it to get the y? You made it multiply by 3, right? So the answer for this one is going to be, yep, y is just means equals 3 times x. That's all there is. Nice and easy. Straightforward. If you take the time and read it and see what the heck they're even talking about. Morning. All right, back to the thingy. 3, for each dollar a customer spends, Mike earns 15 cents tip. So for every dollar they make 15 cents tip. Let x be the number of dollars a customer spends. Match each function, by the way. That's what we're trying to do. So just by the context, you can probably figure out which one this would go with. Probably B. It's the only one that has, what, 15 in it. Makes sense to me. So that's going to be the answer for that one, B. Why is it B? Because x is the number of dollars spent, and if you take that times 50, you make 15 every single x. So if x was 1, you'd have 15. If x was 2, you'd have 30, et cetera, et cetera, et cetera. Okay, what about 4? Just from the numbers involved, can you guess which one 4 matches with? I bet it'd be C. Yeah, makes sense to me. 4 is going to be C right there. Now, this is something I do want to talk about real quick, is that it says 6% right here. What's 6% as a, why is it going, it's going the wrong way? Tech problems. But it's got 6%. 6% is what, 0.06? I don't see a 0.06. I see a 1.06. Anybody know why the 1's there? Well, when you give 6%, that's extra, right? But you still give the original 100% you owe, right? When you tip somebody, you pay the bill 100%, right? Plus the 6% tax. 100% is just 1, so plus the 6%, 1.06x. That makes sense why that's that. And then I guess by process of elimination, number 5, probably going to be what? I bet it's A, yeah. Now this gives you a specific rule on how the function is going to change things. Apparently when you plug into, remember that's what domain is what you're plugging in, you should get out, according to this map, 0, right? And let's just check it real quick. If you plug into here, first of all, PEMDAS, should you square something first or make it negative first? Which one comes first? Exponents or multiply? Which one comes first? Exponents. So first you take the 2 and square it. 2 squared is 4, right? Then there's a negative in front, so now it's negative 4, right? And negative 4 plus 4 is, guess what? 0. It makes sense. I bet you if you took all the other 3 and mapped them as well, you'd get the exact same thing. So there is your warm-up for today. Besides your warm-up, you also need to write down these learning goals in the same probably spot. Just probably right after you wrote warm-up, write learning goal and copy it down verbatim. Your syllabus and multiple intelligences test is due tomorrow. Those are really just glorified checking that you can put things in the Google Classroom. If you did not watch yesterday's lesson for some reason, you need to get caught up and get going on that stuff. Yesterday we did logins for your Reveal curriculum, Alex. We went over the classroom rules, the boring stuff. But it told all the expectations and all, we got all the business out of the way. So now we can just do math. Isn't that going to be fun? Notes, notes, notes today. Heavy note day. Probably going to go all hour. Tomorrow I'll give you guys some time to get caught up. You'll be at home if you're here. You'll have time to work. If you're at home, you'll need to watch this today. Come with questions tomorrow. Your homework will be entirely online. We're going to try going through the Reveal system. Got like 30 problems online where you select different options. And it's harder than Agile Mind, so you can't guess your way through, but it's not impossible either. So it's a good balance, I think. A lot of terms today, a lot of terms. You definitely want to write them down. Here's what's coming up. Like I said, syllabus due tomorrow, as is this multiple intelligence test. And this new one, this is your first real math assignment, homework 1.1. It's online. It's going to be due on Thursday. You got a couple days for it. Check Google Classroom. I will post later today that that's an official assignment. It's through Reveal. You don't need to do anything special. You log into Reveal. You select the homework that says homework 1.1. It opens up in your browser. It gives you problems. You do them. You submit it, and you're done. You don't have to do anything with Google Classroom. You don't have to do anything with paper. You can do it on paper if you want and scan it, but it should be pretty straightforward. All right, let's do this stuff. I'm ready. It's been way too long. In case you forgot, yes, there's the URL for Reveal and Alex. Here are your guys' login codes. You should have got those yesterday as well. They're posted on Google Classroom if you don't have them. All right, big section. Put a big heading. We'll be here a while. This is Unit 1, Relations and Functions. It is difficult. They are just throwing you at every term you could possibly want to know about this stuff today. Kind of mentioned yesterday, I beg you to learn what the terms mean. Math is not that complicated if you know what you're talking about. So if you don't know what the word means, then it sounds like it's impossible, and that's pretty bad. Specifically, you don't have to write this down, but this is section 1.1. Maybe write down this is section 1.1 or something like that. You don't need the whole title. If you go to Reveal and you go to the online textbook there, this would be found on page 3 of your online textbook today. You're welcome to go there, read through it yourself. I'm doing the same lesson they are. I'm going to jazz it up a little bit, but the bare bones of the stuff is still there, so you can always look at that again. The lesson will be recorded, so you got me to listen to again. You got this thing to look at if that still bothers you. Of course, Google, it's all over the place. And here we go. Functions and continuity is the topic today. I would, whenever I put a slide up, a couple things. This is out of the book, and I'm trying to summarize it right here. So this big square box is definitely, I know it's a lot of things. Like I said, I'm hitting you hard today. Take a few minutes and write those down. I have to stop right here and talk about these quite a bit. Definitely the words domain and range, or something to put a star by. Those will haunt you all year long. They should be a review from previous classes. What they're going to step up on in the detail is the terms codomain, one-to-one, and onto. You probably have not seen those before. I didn't learn those terms until I was far older than you are now. These are all really useful terms, though. I would not be writing this stuff down. The book's giving you this long, drawn-out thing. I'm trying to make it concise for you in the box. Word it in things we can understand. There's a lot of new notation, too. As you're writing down the codomain thing, you might think, oh my gosh, what are all these letters? This is confusing. So part of the lesson today is also describing what the heck that stuff even means. As we previewed in yesterday's warm-up and today's, domain is the set of all x values that you can plug into a function. A function, just a fancy word for something that takes a number, does something to it, and spits out another number. Domain are the things you're plugging into this machine. The x's, right? X's are what you plug in. What you could get out, the possible things you could get out are called your codomain. Domain is what you plug in. Codomain is what you could get out. I'll go through many details and examples of this in a minute. Your range is what you actually get out. Codomain is what you could get out. Range is what you actually get out. For example, my codomain of my first hour students is anybody in this class. Those are all the kids I could have in this class. What's my range? I didn't get everybody enrolled in this class here today. My range today are the students whose last names are L through Z. Codomain is A through Z. I could get anybody here. It's possible. The real ones I did get range. One-to-one is a more complicated term. It basically means every number you could possibly get out, there's only one thing that you could plug in to get it. If you want to get out 5, there's not 2 numbers you could plug in to get out 5. There's just one number. This will make more sense when I throw some graphics on the board. Onto is a fancy word for saying when your range actually equals your domain. When you get out everything you could possibly get out, then you're onto. If we dropped all this COVID stuff and all of a sudden had class here every day, and then my range of students, everybody here, would equal my codomain. Everybody who actually comes to school would be all the people who could possibly come to school. Complicated stuff here. And this is only like a third of the terms for the day. So you definitely want these written down. You definitely want to see some examples. They're going to be hard to remember at first because they're brand new to us. Right, let's look at some examples because this is just math talk. What are they talking about? Okay, so, well, Let me draw you a little picture here. Generally speaking, a domain is just a collection of numbers. I could plug some numbers in. So in most textbooks, they just kind of draw it as a blob. There's some blob. It just represents a set. A set, it just means a collection of things. So here's numbers I could plug in. Give me a number. Give me some number. Give me a number. 23. I could plug in 23. Give me another number. 12. Another one. 4. Okay. These three numbers, let's say, are things in my domain. What's domain mean? It's the numbers you can plug into a function. Good, good. And your function's going to take all these numbers and put it somewhere else called your codomain. So you're taking all this function, we'll call it f or something. I don't know what it is. It just stands for something that's taking a number and doing something to it. You could take some number in your domain and plug it into this function, get out something in your codomain. So give me 5 numbers. Give me some more numbers. 87, more. 94, 6, 3, 12. I'll be crazy. I'll make pi or something like that. Okay. So what's domain mean? All the numbers I can plug in, correct? Codomain means all the numbers I could get out. Could. Doesn't mean you always will. So for example, if 23 mapped to 87 and 12 mapped to 6 and 4 mapped to 12 right here, did every single number that you could get out happen? No, it did not. So let's define things real quick. I'm going to use capital D for domain. Domain is all the numbers you could plug in, correct? Here they are. There's only 3 of them. Now, I'm going to go ahead and start showing you some notation. There's lots of different notation. The first one is a little curly bracket. A curly bracket is going to define a set. A set just means stuff. And what stuff can I plug in? 4, 12, and 23, correct? Those are what go in. So you list them. You write 4. It'd be nice if you wrote them in order. It doesn't have to be in order, but I'm going to go in order. And then you kind of put a curly bracket to close it. So when I write D equals this, I mean, hey, these are the numbers I can plug into my function. So far, so good? Okay. I'm going to write CD. Guess what that stands for? Codomain. Codomain means all the numbers I could get out. Could. What are all the possible numbers I could have got out? Any of these, correct? So I'm going to write all of them out. I'm not even going to put them in order this time. Let's just write them down. 87, 94, 6, 3, 12, and apparently pi. That's what I could have gotten out. Did I actually get them out? All of them? No, I did not. My range, and I'll use R for that, the range of the numbers I actually did get out when I plugged everything in. The only thing I actually got out was 87, right? 23 mapped to 87. That's what we're saying, mapped. We also did get out 6, right? And we also got out 12. That's the difference between codomain and range. Codomain is the list of things I could have gotten out, possibly. But did I necessarily get them all out? No, I did not. Are we okay on that concept right there? Okay. We'll do lots more examples too. Curly little brackets are good and stuff like that. Let's stick with this example, I suppose. I'm going to erase these 3 right here. Okay, pretend it's a brand new problem. Ready? Same deal. What's my domain? It's 23, 12, and 4, correct? What's my codomain? What could I get out? 87, 6, and 12. What's my range? What did I get out? 87, 6, and 12. Is what I did get out the same as what I could get out? Ah, that is called onto. I'm kind of skipping around a little bit. Onto, like you kind of should have written down, is when the range is the same as your codomain. And you stop and think, why does that word even make sense? What's the word onto mean? If something goes on to something, what's that mean? It covers it? It's like completely onto it. Well, If I take these numbers and I put it here, don't the numbers that I got out the range cover everything I could have gotten out? That's why it's called onto right there. Make sense? Okay. Now I'm going to give you another example. Different numbers, just for fun. Write down this little blob. And of course, we're not going to be writing blobs all year. These just stands for things on the number line. So usually you're plugging in x, right? Something on the x-axis, some number. Any number on that line would be in my domain or my codomain. All right, I'm going to give you two numbers, 2 and -2. There's going to be some function that does something to it. And here I'm going to have the number 4. Say when you plug in 2, you get out 4. But also say when you plug in -2, you get out 4. What's going on here? They're both going to the same number, aren't they? So for this number, if I pick this number, is there only one thing I could have plugged in to get it, or is there more than one? More than one. This would be an example of something that is not 1-to-1. 1-to-1 means, we'll define 1-to-1 real quick, although that was already in your notes. 1-to-1 means for every number you get out, it came from only one number in. There's only one thing that came to it. Now, this doesn't work, does it? I took a number I got out. For every number you get out, here's the number I got out, 4, right? Did it come from only one number over here? No, that's why it's not 1-to-1. That's what we're going to call that. Typically speaking, you're not going to see this. I'm not going to spend all year drawing blobs and arrows and stuff like that. I'm going to be drawing graphs, right? And what's going to happen is, again, here's the x-axis. Those are the numbers I'm plugging in. So what's that about? My domain, or my codomain right here. That's about my domain. Yep. So x's are about my domain. Won't write that all year either. You also got the y-axis. That's about what you get out. But I'm going to say it's your codomain. No matter what graph we do, what numbers could you get out? Is it possible I could draw a graph that would go this low? Possible here, 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 here. It could go pretty much any height I wanted, correct? Which, if you go back to the notes real quick, is saying the codomain, which you could get out, correct? By default, if they don't tell you, this is an important point, if they don't say anything, you can assume you can get out all the numbers here from way down here. How far down can you go? -10, -100. You can go down to -infinity. Okay, keep going down forever. How high can you go? All the way up to positive infinity. So when they write this like this, -infinity to infinity, what they're saying is that this can go all the way what? Down to the top. Any number I could get out. So by default, and if you didn't write that down, make sure you do, because it's an important point. They're not always going to say this is the codomain. Sometimes you got to expect it. By default, your codomain is, this is another way to write it. You're going to have to, you'll get used to these things as we go. This means all the numbers starting from -infinity, which is way down here, to positive infinity. The parentheses mean it's a range of numbers. So it's everything starting from here and ending towards there. So everything down here all the way up to the top. By default, that's what's going on. Okay, that's a lot already. Does that make some sense? If you go look at the terms. I don't expect you to have memorized like the first thing, but the examples make sense so far. Okay. On a graph, let's keep talking about graphs for a second. I'm going to give you, let's do an example real quick. A graphical example right here. Here is some kind of function right here. Some kind of line, doesn't really matter what it is. Looking at it, Just looking at this picture, can you tell me what the domain is, the numbers you can plug in? Anything horizontally. How about right here? If I plug in this number, does the graph exist somewhere? Yeah, down here, right? How about right here? Yeah, there. In fact, no matter where I plug in, it exists somewhere, correct? So when we read graphs, for the x's you read left to right, and for the y's you read bottom to top. So starting over here, how far to the left can you go? These are negative numbers, right? How far negative can you go? Negative infinity. So I can start way over here at negative infinity, and all the numbers are cool. I can plug them all in until where? Till positive infinity. That comes up so often, that's all the numbers, isn't it? All numbers are okay. And they have a special letter for that that might show up in your homework. It's an R with 2 bars. It just means all real numbers. It means all the numbers. What's the codomain? And notice I didn't tell you anything, did I? I didn't tell you what it is. So by default, what is your codomain, guys? Negative infinity, infinity. I could get out everything. So in this case, it's the same thing. You can either write this, you can write this. This means that. They both mean the same thing. R means all the real numbers from negative infinity to infinity. That's what I could get out. What did I get out? What's my actual range? Does it go all the way down to negative infinity? Yeah, eventually, right? Does it go all the way up to positive infinity? So in this case, my range is also all the real numbers from negative infinity to infinity. Is this onto? Look up the term. I know it's brand new. It's okay. What's onto mean? What's that? When the range equals the codomain. Does the range, is it the same as the codomain? So this is onto. That's all you got to write. It's onto. Yes. It's a yes/no problem there. Is it? Yeah, they're the same. Now, one-to-one, let's talk about that. What did one-to-one mean? That was a weird definition a second ago. Anybody got that definition written down? I erased it already, so I don't know where it is. For every number you get out, right, there's only one number you could have plugged in to get that. Does that make sense? Okay, so let's just pick a random number. How about right here? At 6 or something like that. Is there only one x value you can plug in to get to here? Yeah, right here, correct? There's no others. How about, let's get out -5 right here. Does that only come from one x value? Yeah. Does it seem like no matter what y value I give you, you can only tell me there's one x value that goes with it? So what's that mean? It is one-to-one also. This is one-to-one and onto. There's a lot of stuff. Give me some feedback. Is it making any sense? Okay, good, good. Let's try one more graphical example. Here's some funky looking U thing. We have a lot of funky looking graphs, but no matter what it is all year long, you're going to do the same analysis on it. Let's go through all 5 of these again. Domain. That's the x's you can plug in. Is there any x you can plug in that the graph doesn't exist? Right here, does the graph exist at this x? Yep. How about over here? The picture's not here. You got to use your imagination. What's the graph keep doing? Going up, right? So does this x work? Yeah. Does every x work? From where? From negative infinity to? Awesome. You guys are smart. I like this. You guys are going to be okay. Or if I want to get all fancy, I can write a double bar with an R, which just stands for all the real numbers. Either one's okay. What about my codomain? Did I tell you what the codomain was? So what is automatically? Same thing. I could, no matter what picture I would have drawn up here, would have existed somewhere from negative infinity up to infinity. Remember, these represent 2 different things. Domains are about x's. That's about back and forth, right? Horizontal stuff. Codomain is about y's, what you get out up and down, right? Or could get out up and down. what do you actually get out as your range? Does it go all the way down to here? No. So should I say negative infinity? Heck no. Tell me the first, I'm going to go up, always bottom to top, left to right, top, bottom to top. Tell me the first y value where this exists. Okay, now does it actually touch right there? According to my little dot, it does, doesn't it? So you're telling me basically from -3, -2, -1, 0, 1, all the way up to infinity. Now this is a little tricky. You would think I would write from -3 up to infinity, and you'd mostly be right, but I want you to know this little notation. See that bracket? Draw that bracket. We'll do this all year long, so it'll just get easier and easier and easier. The bracket has a special meaning. It means it can be that number. Does it actually equal -3 right there? Yes. That's why there's a bracket. Parentheses means it gets close to it but never touches it. Notice with all these infinities, no matter how high I go, do you ever get to infinity? That's why this is here. It means you get close to it, but not actually touch it. Brackets mean you do touch it. Parentheses mean you get really close to it, or you can keep getting closer and closer, but you never actually get there. Kind of like if I sawed a student in half. If I saw you in half, I take another half of you and saw you in half. I take that half and saw it in half, and I keep. No matter how many times I do that, will I ever have nothing? But I get really close to how many students if I keep sawing them in half. Well, if I keep taking one and saw it in half over and over again, here's your student. Oh, here's now a half a student. Here's another half, right? Another half, another half, another half, another half. How many students do I almost have right here, like compared to the whole? Basically 0, right? I'm getting closer and closer to having nothing, correct? But do I ever have nothing? I get close to nothing, right? So if I was saying this one, well, how many students could you have? I'd put a parenthesis with 0, because can I actually have 0 students? Remember how many times I cut them, I still got a piece of a student. Could I have a whole student? Could I have 1? Yeah, what's this mean right here? It means anything from 0 to 1. Can it be 0? No. Can it be 1? Yeah, very good, guys. All right, that's outstanding. Back to this thing. Is it onto? Look up the definition again. I know it's still fresh. I do not expect to have you have these memorized right now. No, why not? Range is not equal to the codomain, correct? Onto means I mapped it onto every number that was possible that did not happen, correct? Just from -3 up, so this is not onto. Not onto. What about 1 to 1? What's that definition mean again? For any number I get out, I should have only gotten that from one thing. So let's pick a random number. 7. Here's where it is at 7, correct? Is there another spot where it's 7? Oh, right here. Okay. So how many different numbers could I plug in to get out 7? Oh, 2, not 1, right? So this is not 1 to 1. 1 to 1 means, yeah, that's a weird definition, isn't it? It's wordy. Like for everything I get out, there's only one thing I put in. I wish there was like a test to check to see if something's 1 to 1 or something. You know the vertical line test? Remember that thing? That one, if you take a vertical line and it passes through it one time, it means it's a function. There's another test that will tell you if something is 1 to 1 or not. This one was 1 to 1, wasn't it? Okay. I'm going to put not a vertical line, but a horizontal line. How many spots does it hit the graph at? 1, 1, 1, 1. So this thing is, guess what? 1 to 1. Over here, how many times does it hit the graph? 1 right there. Ooh, guess what? This is not 1 to 1. So let's kind of summarize that right now with a new test called a horizontal line test. Oh. And let's say this. If any horizontal line crosses the graph at only one point. This one would fit that bill, right? And this one was what? 1 to 1. So if you do this, then the function is 1 to 1. And I should say IFF, like if and only if, don't worry about that, geometry stuff. This is only true if it passes this test. So what's it mean if it doesn't cross only one point? Then it's not 1 to 1. So that's a lot of terms right there, but please write down the horizontal line test. That's a lot easier just to look at a graph and say, okay, oh, that's good. That is 1 to 1, right? This one is not 1 to 1. I could throw up any graph and then really quickly you can tell me if it's 1 to 1 or not. Here's some test graphs. 1 to 1? Mm-hmm. 1 to 1. No. 1 to 1? No. That's how easy it is to check for 1 for 1. Don't be picking lots of random X or Y values and say, oh, there are 2 points here. Just do the horizontal line test. You guys all right? Okay. Hopefully with the examples and the terms written down, that'll be enough to get you guys by. I wish that was all we have for today, but we're just getting started. Really quickly, let's go through this example here. Tell me what the domain is for this first graph. Does it go all the way to the left and to the right? So what is it? Negative infinity to positive infinity, all real numbers. What's the range? That's up and down, right? How far down does it go from negative infinity? Does it go all the way up? No, it stops at where? 0, good. Would I put a bracket or a parenthesis on the 0? Very good, bracket, does actually touch it. But could I get out more? I could get out everything from negative infinity up to infinity. So again, this is hard, emphasizes that codomain is what I could get out, range is what I actually do get out. Good, good, okay. Let's move right along. I'm not gonna do a table, forget that. Ooh, look at this real quick, example 3. Is this 1 to 1? I don't know, it's hard to tell, isn't it? How about this? Horizontal line, we're good here, right? We're good, we're good, we're good, we're good. It looks like this is like a straight line. Do you really think it's a straight line? It never quite touches it. So actually, technically, this is 1, 2, 1. Is it on to? No. Why not? If you know the terms already, I'm impressed. Look them up again. What's on to mean? It's okay. I do not expect you to have memorized. Does the range equal the codomain? Well, what's the range? It looks like you can get out everything from 0 up. Is that fair? Why does this thing go? It goes the wrong way when I hit it. Where's the example? It's the weirdest dang thing I ever saw. Okay, there we go. It only gets out what, 0 to infinity? Roughly. Does it actually touch 0, do you think? No, it does not. So that's a problem. Yeah, but so actually this one's range, you would write what? Parentheses 0 to infinity, because it never actually touches 0. It's not onto because it doesn't touch everything you could get out. Everything you get out would be from negative infinity up to positive infinity. Cool? All right, we're running out of time. I want you to really quickly write down these definitions here. We will continue this lesson tomorrow. Did not expect it to take this long. These are heavy things. At the very least, your job today is to understand domain, codomain, range, 1 to 1, and on to. That's a lot of terms right there to memorize. Maybe that's a good thing we're stopping today because I don't want to overload you. Those were the tricky ones. Considering this is taking longer than I thought, I might extend the homework, but don't count on it. For right now, you can get on reveal. You can look at the homework assignment. You can jump around. You can skip problems. I would start attacking any problems or answering anything that has to do with, guess what? Domain, range, codomain, one-to-one, and onto. These terms are far simpler to understand. But unfortunately, we won't have probably time to discuss them. There's 3 kinds of graphs you might see in your life. If you do have time, you can copy down those graphs up here. They're going to go along with them. But essentially, the word continuous just means it's a nice, smooth, connected curve. And that's what a lot of things we're going to do in life is. When a function is graphed with a line or an unbroken curve, it's nice and just one smooth motion. You can draw it without lifting up your pencil. That's a good middle school definition, and it holds. Be drawn without picking up your pencil. This one over here is continuous because I drew it without picking up my pencil. There's problems sometimes in graphs. Sometimes in a graph, the function explodes, or there's an issue, or it just doesn't exist somewhere, and there's a gap, or there's a break in things. That's a good example of something that's discontinuous. It's almost continuous. I can draw it smoothly here. I can draw it smoothly here, but do I have to pick up my pencil to do so? Yes, that's what makes it discontinuous. Last kind of graph might be something discrete. That's like a couple lot in class. That's not a natural thing. It's more like a stat thing. It's going to come up sometimes. But discrete means it's just a bunch of isolated points. So just points drawn, not lines, not curves. Loser, lone points. Lone points. So when you look at a graph, that's basically, you just have to know what these terms mean. If you know what they mean, then you're good. Once you got the vocab copied down, drawn a couple pictures, that's good enough to probably answer questions about that too. So try, and I want your feedback. So let me know how it goes online. Let me know how you struggle. There's some sets in there. There's things we haven't covered yet. Try to answer what you can. Really give me your feedback on things. I need to know how the curriculum is treating you guys. And once you got those all copied down, you are good. Those of you at home, there is the picture of what a continuous graph looks like. Nice and smooth. You can draw it without picking up your pencil. It's all connected. Discontinuous, still pretty smooth, but you do have to pick up your pencil to do it. And discrete, isolated points there. That concludes today's lesson. Tomorrow we will touch it up and finish section 1.1 over all this stuff. Try to start working on your homework. Try to answer any questions that are purely about domain, range, codomain, one-to-one, onto, or these 3 terms, continuous, discontinuous, and discrete. So good luck and have a good day.